Bismillah ar-Rahman ar-Rahim. We would love your recording, okay, to show you something that might help you in the quiz. Remember last time in class, we did show how to find the settling velocity using Stokes Law. But the problem is that Stokes Law need to be applied initially with this equation, and we have to check if the flow is laminar. If the flow is not laminar, then we should change the equation to the Newton's equation, and this is what we did here. And with it, we have to find the CD. And all depend on if the real number is less than or equal to 1 or greater than 1. Okay, we did show you this example, and in this example, after we find settling velocity, we did check the number. It was 0.53, and that is less than 1, and that means that this settling velocity is correct. Why we have to do all of this? Settling velocity, it is needed in order to design sedimentation basin and settling tanks. And once we went to the other example, we find out the settling velocity 113.8, and then when we check a number, it was higher than 1, which means that this settling velocity 113.8 is not correct, and we cannot use Stokes law. Then later on, we find CD, and we find settling velocity 97.1 meter per hour, but that is not it. That is not it. We have to do simple trials, iteration, until you get, remember what was the thing coming from here, 97.1? Now, after iteration, we assume the settling velocity, 97.1, and then we find the right number, CD, and the settling velocity, and then we could use the same thing, find the right number, and keep going until you find out the actual real settling velocity for this type of particles. I did develop an Excel sheet that might help you determine this very easy, and you will see this in the quiz. In the quiz, you don't have to do iteration because you might spend 1 hour trying to iterate and find the final solution. So I put this code, and I will put it in Teams so you could use it for you to determine the settling velocity using Excel. So what was the density? It was 2,650 kilogram per meter cube. And mostly you should change this if you have a different density of particle. Density of the fluid, of course, density of the fluid, it's using this temperature, 15 Celsius, and that's 999.1. This would be given to from the tables in the book. Mu is, this is of course, mu has to be equal 1.139 10 to the minus 3 from the temperature. This is viscosity. That is almost the same thing. And the diameter is 200 micrometer. Okay, so this is 200 micrometer. And that is, if you divide this by 1,000, that is 200 millimeter. So after we do this, let's just go this here. After we just put all the numbers, now this settling velocity will come to you 113.8 or 114 meter per hour. We find a number is 5.54. This automatically will come. So if you put, for example, 0.1 diameter millimeter, you'll get a different settling velocity, and it will check a number, and that is fine, 0.69. That's less than 1. Again, let me change something. This is not 0.5. This should be 1. This is 1, and we should make it less than or equal. Make it like that. In Excel, I can't do the things. And this is it less than 1? Some people is more strict on this, so I'll keep it less than 1 according to the author of the book. So I'll keep that 0.2 because this is 200 micrometer. And then this is the settling velocity. This is a number that automatically will come, and this is the CD. Is RE less than 1? No, it's higher than 1. So we have to do iteration. So the iteration, remember here, what was the number? We should be close. You should guess the velocity close to this, 113.8 meter per hour. So what we're going to do here, we're going to assume 113.8, and we're going to, this is, since it's meter per hour, what I need is to find the round number, find CD, and then find the new VS. This new VS, this one, and this all VS has to be equal to zero. The difference between them has to be equal to zero. So the delta VS is the subtraction of VS of the second one minus the VS of the first one. So how could we make delta VS zero and find the initial settling velocity that will be the final? We go to data, see here data. We go what if analysis. You go to goal seek. We're gonna set this one, this box or this cell to zero. So we know delta V S equal to zero. By changing what cell? By changing this cell. So we go and look at the solution. See, 1 second. And 1 second. The delta VS is 3.44 10 to the minus 5. That is beautiful. That is zero almost. So what is the answer? The settling velocity, the real one, is 86.4. 86.4 meter per hour. And that is almost the solution given in the notes. 86.4, 86.5, it's the same thing. So I think this is it. And we would love you to solve this problem with this Excel sheet. And I will try to send you another video for filtration and finish up the chapter before I give you the quiz. Thank you.